start now. So where we are at the moment is the fact that we realize that if we have a class teacher, even this sort of simple modeling of a teacher, and then we have a special ed teacher, they share a lot of these properties, and it sort of seems to be extra work on duplicating all the functionality in this special ed teacher class. So there needs to be a sort of a better way to do this. Also, this means that if we add another property, if we decide that all the teachers need additional information, then we need to include it in this class and this other class. And that also means that we need to do duplicate work, and that also means that there are a lot of potential errors that may occur when we're doing that. Another way to do this would be just to include the special hours in the teacher class, but that doesn't seem like a good idea either, because teachers don't have special hours, only the special ed teachers have those special hours, and having like an empty attribute for all teachers isn't really convenient. So what we are going to do in this case, we're going to talk about something called inheritance, where the idea is that we can have a class that inherits the properties of another class. Another typical way for this, another typical need for this is something like this case, where we have student and teacher classes, and now these are the teacher is not a special version of student, but the student and teachers have a lot of things in common, like they both have names and email addresses. But then in addition, students have some of their own properties like credits, and teachers have some of their own properties like teaching years and maybe the room they are teaching in and things like that. So again, there are some common shared properties, but we probably couldn't write a shared class for both of them. In both of these cases, whether it's this one or the one we saw an example here, the one with the teacher and the special ed teacher, we can make things easier by using the inheritance. And as I said before, the idea is that a class inherits the properties from another class. And for this one, we need some new terminology. So basically, the class which inherits something is called a subclass. So for example, a teacher could be a subclass of a person, or the special ed teacher could be a subclass of the teacher class. And then the class that's inherited is the superclass. So in this case, the person is the superclass of teacher and student, and in this case, teacher could be the superclass of special ed teacher. So inheriting means that class is also an instance of its superclass. So teacher and students are also persons, but not all persons are teachers or students. And the same applies for this one. The special ed teacher can be made a subclass of teacher, meaning that special ed teacher is a teacher as well, as the name sort of implies, but not all teachers are special ed teachers. And we can do the actual inheritance, but by just writing the name of the superclass in parentheses in here. So basically, by doing this, we tell Python that special ed teacher now inherits the teacher class. Okay, let's see what it means. So as I said, inheriting a class means that we inherit all the properties of the class. So let's write a special ed teacher object. And but it's called Simon. Have some kind of email address. Say that Simon has 20 hours and then 8 special hours weekly or whatever that means. So okay, let's try to output this one. What happens now. What will be the outcome? Think about this for a minute. So we haven't defined the STR method for special ed teacher. What happens when we output it? So let's try it out. There's oh, sorry, an error over there. Let's do it again. So now what we see is we get the output, we get sort of meaningful output. And if you look at the output, it displays the name and the email, and then the number of hours per week. So it's basically using the str method defined in here. So the idea, as I said before, is that because this class, the subclass inherits all the properties of the superclass, it also inherits the str method. So in this case, we can, when we call it by using the print function, which implicitly calls the str method, then it uses this definition in here. Okay, so in this case, it's a bit problematic in a sense that it's missing one of the attributes. It doesn't provide the information for special hours per week, which is sort of logical because teachers don't have special hours. But in this case, it's probably a good idea to override the method in here, so we can well, let's do this one. Again, I'm copying and pasting something, so there needs to be a better method, and there is, but we're going to talk about that in a minute. Something like, so now when we execute it again, we can now see that it uses the str method defined in here. So the basic idea in here is that if we haven't defined the str or any method in the subclass, but we have defined it in the superclass, then Python automatically uses the version defined in the superclass, because special ed teacher is also a teacher. It's implied here, it inherits the teacher, and that's why it is also a teacher. But if we define a method again in this class, then it uses the overwritten version of the method. Still, if you create a teacher, create that again, and if we output oh, that's a very good question. Why does it say 20 special hours? Why does it say 20 special hours? There's actually an error in the special ed teacher class. Can you locate it? If you look at the constructor of the special ed teacher class, yeah, exactly. So we're setting the wrong parameter attribute in there. So let's try it again. That's a really good catch. So now it's 20 hours and 8 special hours per week. So good point. Excellent point in there. There was an error, and it's a good thing that you got it. That's a kind of error that's sort of easy to make, and but can be really difficult to catch if you don't test your code properly. Okay, so now it seems to be working. And for a teacher, using the print method now calls this str function from the teacher class. So now it depends on whether you have a special ed teacher or a teacher on which version is used. Okay, now if we're doing it like this, it seems that there really isn't no point. We're not, I mean, yeah, special ed teachers are also teachers, but what's the point in inheriting if we need to do everything again in this class? And the point is that we don't need to. We can reference the superclass in the subclass. So what we can do is we can call the superclass methods. So for example, we can utilize the constructor in here, and we can access the superclass by using the function super, and then we can, for example, call the init method from the superclass and then just apply the name and email and hours as parameters or arguments in this case, like this. And still we can access the attribute from the superclass. So we have the name Simon set, even if we don't do the actual setting of the attribute in this subclass, because we are calling the init method from the superclass, which now sets the values of attributes. So this subclass also has the attributes name and email and hours, because this subclass is the special ed teacher is also a teacher. So it has all the properties of the superclass as well. So it has a name, attributes name and email and hours, like the superclass has. We can also utilize this in the subclass. If we decide that we want to use the str method from the superclass, we can do something like this. And then we can add something like, and use the string and self special hours per week if we want to. So we're basically utilizing the output of the str method from superclass, and then we just concatenate something at the end. Why am I writing hours with an E all the time? So whether it's something we want to use, or then if we don't like it, we can also write the whole thing again here in the subclass. But the basic idea is that we can access all the properties of the subclass by using the super function call. Just remember that it is the function call, so you need to have the parentheses after that one. It's especially easy to forget if you've been doing something similar in another programming language where there might not be those parentheses. Like myself, I'm sort of accustomed to the way used in, for example, in Java, so it's difficult to remember those. So the super function calls refers to the corresponding superclass type object. So a teacher object with all these same properties. Okay, let's look at the slides again. So we talked about this one. We are inheriting, and we can refer to superclass members like this. Yeah, let's try something out. So let's say that we want to utilize some private members for this code. We want to do like the proper encapsulation for the teacher class, and let's say that we want to, for example, hide the hours from the client, so that the client doesn't by accident, for example, set the hours to be a negative value or something like that. So let's change it to be a negative value, and then let's write a getter for this one. Like this, and then we need the annotation stating that it's a property, which is great. So now this one is also visible for special ed teacher. So as we see, we get the hours, but now we can start to think that, okay, maybe we would like to get like the complete amount of hours. So instead of getting that, so we would also want to have the special hours included in this number, which is sort of, I think, logical that if you're looking at the numbers, number of hours by a teacher, you want to get like the total number of hours instead of just these. Now it's excluding the special hours. So what we need to do in this case is just again rewrite the getter in here. But now there's a problem. Let's see what happens. And now what it says sort of bound method special blah 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 blah. And what is the actual problem in this one is that sorry, we're missing the property. That was the first problem. Let's try it again. And now we get an attribute error. It says that special teacher object has no attribute hours. What is the problem in this one? We also add the special hours in here, but why is this problematic? Gives us the same exact error still. Special teacher object has no attribute hours. So what is the problem here? Yeah, it's private. So the thing we talked about last week about the encapsulation about private attributes, it also applies to this inheritance thing. So the subclass can't access private members of the superclass. And in this case, it can be sort of problematic. We can do something. We can try to do something like this. So let's get the hours from superclass and then add the special hours. And this one works. Okay. So this is fine, but this can be still sort of problematic because there are occasions where we want to encapsulate, we want to hide things from the clients, but we still want to provide access to those things for the subclasses. So we might want to think that the special ed teacher can actually access the hours directly, but the clients don't. And the way to accomplish this is change the visibility of hours from private to protected. And what we can do is instead of 2 underscores, just include 1 underscore. And now the hours is visible for the subclass. So now we still get 28. It isn't private, but it shouldn't be visible for the client. So the basic idea of these protected members is so we can have a public attributes like self-name, which are visible to client and visible to subclasses. We can also have private members like we did before with 2 underscores, which are visible to client and are not visible to client and are not visible to subclasses. But then we have protected members which are visible to subclasses but are not visible to client. And now something you need to realize on this protected thing is that in Python, these protected members usually actually are visible to client as well, but the underscore is sort of like notation telling that the client shouldn't access that member as is. Well, like we discussed last time, even the private members can be accessed by the client if the client really wants to. In Python, they are not it's sort of easy to get around that whole thing, but it's more about telling the client that they're not supposed to access and change the values of those members which are protected or private. So they are only meant to access those by using the possible getters and setters provided by the classes. But anyway, so here the basic idea is that basic idea is that one underscore means that it's protected from the client, but not from the subclass, and two underscores means that it's hidden from everyone. And which one you should use really depends on whether you want to provide access for subclasses. So whether you want the subclass, for example, to be able to change the value of hours, or whether you are, because in this case, we have a property here, we provide a getter for the clients, but the client can't change the value, but the subclass can change the value. So yeah, is it okay that the subclass instances of the subclass can change the value, or should it be hidden from subclasses as well? And this is something you need to decide on each occasion separately. It sort of depends on what you're doing. I think most of the time it's okay to provide access to the subclasses, but in some occasions it could be fine to also hide the attributes from subclasses and decide that they can only be accessed in the superclass. Okay. Let's see what else. Then this is actually something we talked about last time. Class can return an object of its own type, and this is actually something I'm going to talk about in a minute a bit more. Was there something I forgot to include? No, I think this is all. So let's talk about something else, and let's talk about let's get rid of the special ed teacher, or at least for a while, and let's talk about teachers. So let's say that we have two teacher objects. We have Z with 25 hours, and then we have another one. This one is called say, why it's so difficult to come up with names when writing these examples. Zane has 30 hours per week. So so what is happening here? What do you think happens when I execute the code? Which one is larger in this case? Yeah, we do actually get an error. That's an excellent answer. It says the type error, and then the larger than operator is not supported between instances of teacher and teacher. So Python actually tells us that it doesn't know how to compare the teachers, how to compare the teacher to another teacher, and which is sort of logical because Python, well, it could be really difficult to sort of know that without explicitly stating how to compare this. And we can get around this by actually doing something called operator overloading. And the idea is that in operator overloading, we write a special method to a class, which Python then knows how to use when we are comparing objects to other objects. So if you want to have the access to greater than object, we can just implement method called tt with, again, 2 underscores in the beginning and the end. So let's see how it works. So we get the self attribute, and then we have another teacher. Like this. And now we need to decide how we're going to compare teachers. And let's say that in this occasion, we are interested in the number of hours the teachers have. So the teacher who has more hours is considered larger than another teacher. And so for some reason, we want to be able to organize or sort them in the order based on the number of hours they're teaching and so on. So what we do is we find out that if the hours by self is larger than the hours, you can also actually use the getter because we have one sorry. So we can just do it by returning this, or if you want to write it in this longer form, we can, sorry, turn true or return false. So this might be easier to read, but the basic idea is same than returning the result of this comparison in here. And now if we execute the code, what do you think will happen? Which one is larger? Yeah, chain should be larger in this case, as it because chain has a bigger number of hours. So if we change the number of hours by Z to 35 and then execute it again, then that is larger. So this is really convenient because using these operators in comparison is logical, and we can get the functionality by just writing the GT method. The good thing about this is that also, if we want to, we can implement the less than method as well. But if we don't, then Python knows to use this one in that comparison as well. So we don't necessarily need to implement them both, just having one is enough. And now Python also knows that if T1 or if T2 is larger than T1, then T1 must be smaller than T2. But if you want, you can implement them both in like a rare occasion where it isn't exactly equivalent, but yeah. And this applies to all operators. If we want to have the equal to operator, let's do that one as well. So again, we see what is the name of the operator. And again, this is an example of things you don't need to remember. It's easy to Google for which was the actual method for any of the operators. Some of these can be, for example, GT sort of an EQ might be easy to remember, but Googling this is like a couple of seconds, probably takes no less than a couple of seconds to find out what was the, just do something like Python and operator overloading, and then you get a list of all these methods really easily. So equal to is EQ. Let's do that one. It's again compared to another teacher, and now we need to decide on how are two teachers equal. Is it enough that they have the same amount of hours, or do we want should they have like a same name and same email address as well? Let's decide that having the same amount of hours is enough. Oh, that doesn't work. And now when we try to compare them, so now when we execute this one, they are not equal, but if we change the number, so they both have 35 hours, then they are equal. And again, implementing the equal method also means that we have the not equal method implemented, so this one works as well. So we get two operators on the price of one. So this is really useful if you're writing kind of objects which should be compared. It's not. I mean, you shouldn't do this with all possible classes, because not all objects can be compared. The equal. Yeah, it's probably appropriate to say that two objects are equal for almost any class, but saying that one object is larger than another object is it's not useful for all possible classes. It sort of depends on what you're actually modeling with those classes. So whether we should actually say that one teacher is larger than another really depends on what we're doing inside the program. But if we want to compare them based on the hours, then implementing this GT or LT method makes the comparisons really easy, because we can just use the standard operators. There are also arithmetic operators which we can overload. Let's see an example. Let's do something other than teacher for this one. let's have a glass box, and let's say that box has some kind of name in this case, and then it has the amount of stuff in it. Let's do this really simple version. Yeah, that was exactly what I was aiming for. Oh, there we see one current face. That's what it is. And then let's have the SDR method for this one because it's easier to see what's happening. And then if we add the add method, for example, which if we take a look at this one is for the plus operator. Let's see. So we get self, and then again we get the other one, which is a box as well. And now we can decide that if we add two boxes together, then we get another box. Something like this, for example, and so let's have a couple of boxes. So now it's supposed to call the add method for that one, and the third box is now called little box and big box with 30 kilograms of stuff. So it gets the return value from this add method. And again, not all objects should, you're not supposed to be able to add all objects. It's not logical to count, to add two teachers together or something like that. But in some occasions, it's useful to have the support for this plus operator, especially when you're doing mathematical stuff, but in other occasions as well. And again, you can add the support for whatever operators you want to. You can have the support for subtraction and multiplication and division, and even for integer result division if you want to. There are also other operators supported. Again, Google this if you're interested or when you need to remember this. But the same principle applies. So basically, you see the operator, you see the method, and then you implement the method, and then you can use the operator like we do with this one, for example. Then let's talk about one final thing for today. So quite often it would be useful to be able to iterate through our own object. And let's see an example about this one. And let's have, so we're going to need a couple of classes for this one. Let's have a class called record for this one. And by record, I mean that's like this LP record, like this. Yeah, you know what I'm talking about. Self, and then let's say that we have title for this one, and maybe we have we probably have an artist, and then we have a title, and then let's say that we have a well, maybe that's enough for this case. It's an example anyway. And again, let's have the str for this one. Something like this. And then let's say that because we have this class for record, we want to have a class for a self where we can store these records. Let's call it record self, or it could be a box or whatever we want to call it. Anyway, it's like a storage for these record type objects. And we could have a different methods for this one, for example, searching for a specific title or searching for records by specific artist or whatever we want to. But in this case, we're going to do, again, a rather simple version. And let's say that we don't really need any parameters for the construction. We don't really want to, there probably isn't the name for record self. Instead, we're going to have a list where we are going to store the records. And then we need a method for adding a record. And what we do is we just append it at the list. Something like this. And that will be enough at this point. So let's create a couple of records. Some the Beatles, Revolver, that's a record, and another one. The way I'm going to, let's have, see how, if I can actually remember the names of 3 records. Let's have one more. Let's have one more, which is going to be U2 and Catalan. It really isn't important. And now we can add, let's create another self, or not another self, but a record self object. And then we can add all the records in the record self. Like this. And now we don't have any getters or setters for record self. So we probably should have something where we can return a single record by something. But we could, it's also probable that we want to be able to iterate through all records in the self. And the easiest way to do this is just use the for loop, like we've been using with other data structures, for example, with lists and dictionaries and with files and with strings and with whatever. So it's really useful. And the way to perform this functionality with our own class is implement two methods. So there's a method iter, again we need these underscores, and there's a method next. And the idea is that for the iter method, we initialize the iteration. So basically, we're probably going to need a variable which holds like the current record. Let's call it n. And other than this, we just need to return the class which is, or object which is used for iteration. And usually it's just the same class we're using in this one. The reason why we are, so we are returning an object where Python can find the next method. So it's possible to write a class which does the iteration for another class, but typically we write it inside the same class like we do in this example. And then we need the next method. And the idea of the next method is that we just return one of the records if there are any more left. So we start from 0 and then we go on if there are records left, so we can check that if n is smaller than the length of the number or the number of records, which is basically like this one, and if it is, then we increase the n by 1 and return the record. And this is can be sort of problematic at first, because in this case we need to increase the n by 1 to become 1, but we also need to return the record at location 0. So we can do it, for example, like this. Let's increase it by 1 and then return the item at n-1, for example. And if there are no more records left, then what we do is we just raise this special event, which is called stop iteration, which tells Python that we can't go on iterating anymore. So let's see how it works. So let's see, and now it iterates through all the records in the record shelf one at a time by using the code we just wrote, by using the rules we just wrote. So it picks up the records from the record list one at a time, which is really convenient for the client. The client doesn't need to know how the records are stored in the record shelf. Client doesn't need to know if there's a list or dictionary or whatever, but it's convenient that the client can iterate through the records in the record shelf. And to do that, the easiest way is just to use the for loop like we've been using it before. So to provide similar access in our own object, we just need to implement two methods, iter and next, like this. So again, it's probably something, if you haven't done this in a while, you probably need to Google it for it, but the actual mechanics it's quite simple. And it's really useful. It's probably more useful than you think at the first place. Whenever you're writing a class where you're storing several, where you're storing several objects, it's probably a good idea to provide a way to access those one at a time by iterating through. Not all the time, but often. Okay, this is pretty much it about object-oriented programming. So next week we're going to talk about functional programming, and the topics we're going to talk about are things like we start with list comprehension, which was mentioned earlier, but we're going to get to that in the detail, and then also about dictionary comprehension, and then we're going to talk a sort of a complex concept in programming called recursion, where the idea is that we write functions that call themselves again and again. It's a really powerful tool for some occasions, but it's also sort of difficult to understand at first. So we start with, or we're going to talk about with some sort of really simple examples. Okay, do you have any questions about the things we discussed today or anything else?
Yeah, I have a question on the topic of getters and setters. Yeah, in the exercises I came across a thing. Yeah, and that is there any difference of using the at what is it like a property, like the I figured it's like a static method or something it's called with the at, but we can like create a setter even without it. Like only difference was that if it was like at property, then the attribute was called like dot and like an attribute of the object, and if it was without the property, then it was like a method like called with the brackets at the end.
Yeah, you're absolutely right. No, there really isn't a difference. So what are you saying is that if we have an so if you have an artist which is a hidden object, we can write something like sort of just artist like this and then return self.artist. And if you don't provide the property for this one, then you can just call it call the method artist, and then provide the parentheses, and then it works.
Yeah. Okay.
But
so
then
there is
if
no
we have
difference.
the property,
okay.
then we can use it without the parentheses. No, the reason we're usually using the property is that in Python, if you have attributes which are not private, anyway, you access them without the parentheses. So it's similar mechanics, and so that's the reason. But if you prefer using it like this, I mean, there's nothing wrong with that. This is just this is more Python style way to do it.
Okay.
But if you think about the functionality, how it works, then there's really no difference. That's a really good question. Again.
Thank you.
Anything else? Okay, if not, then thank you for listening. Thank you for coming by. It'd be really boring to just talk to myself for this, whatever time it takes. So thank you, and let's continue this next week. Bye-bye.